Today we are going to do numerical from chapter Force and Laws of Motion, class 9. The numerical says, the velocity time graph of a ball of mass 20 gram moving along a straight line on a long table is given in the figure. How much force does the table exert on the ball to bring it to rest? Now children, this graph plays a very important role to take out some datas. And that is regarding what? Velocities. So over here we will be seeing that this graph is giving two values over here about the initial and the final velocity. That is 20, that is u, and when the ball comes to rest from here to here, over here, so the velocity is 0. So u will be 20 and v will be 0, right children? And we are also able to find out about the time also, that is, it is coming out to be 10 seconds over here, right children? This thing we have understood from the graph. Now what is given in the numerical? 20 gram, that is the mass is 20 grams. So now let us quote down the values one by one, what is given in the numerical. So mass is 20 gram, u is, that is 20 centimeter per second. Again I am speaking that centimeter per second, that is the unit is given in the velocity time graph. So 20 centimeter per second has to be converted into meter per second. So what I have done, that is 20 over 100 is equal to, the answer comes out to be 0.2 meter per second. So this is the second one value which we have got it from the numerical. Now time is 10 seconds, rest, it is 10 seconds. V is 0 when it is coming to rest. Yes, I have written V is equal to 0 meter per second. Now to find out the acceleration. Now the question says how much force does the table exert on the ball to bring it to rest? That means some frictional force is also applied to come to rest. Of course, frictional force will be applied on the ball when it comes to rest, of course. So now for that, first of all, we will take out the acceleration. So acceleration formula, of course, it is coming in my mind, that is v minus u upon t, because all the three values are given over here. So c over here, right? Now we will put the values one by one in this formula. So v is 0 and u is 0.2 and time is 10. So I've quoted the values over here. After solving it, I have come to the conclusion for the answer. It has come out to be minus 0.02 meter per second square, right children? Now children, when it is coming from here till here, of course the graph is also telling about the retardation also. That also we have seen from the graph. Now we know that, and I have told you that the frictional force is also applied to get the ball to rest. So F is equal to, that is m into A. Now what we have, that is m is 20 gram. So what we have to do it? We have to convert this gram into kg. So what we will do? 20 over 1000. So the value comes out to be 0.020 kg. Right children? And acceleration, of course, over here we have calculated. So acceleration also we have in hand and mass also in kg we have it. Now after this, now we will apply these values in this formula. So F is equal to m into A. So mass is what? 0.020 into acceleration is what? Minus 0.02. Now after multiplying, we will get what, bache? That is 0.00040. What? The unit will be N, that is Newton. And negative sign will come because I have told you, because the friction force is applied on the ball to come to rest. So that is why the negative sign is applied over there. Right children? So in the question also, in the numerical also, they can even ask you about this negative sign also. Why it is there negative sign over there? So now you can give the answer very well.